Hello guys and welcome to this video on EIGRP. In this video we will check and study the successor, the feasible successors, and what routes and loop prevention that they use. Alright, so first and foremost here we have the router 1 and we have two interfaces connected. So we have one Ethernet link and then we have a gigabit Ethernet link. So let's see that in the lab. So I have the lab ready here. Let's go to our EVNG. Alright, let's go to router 1. Alright, so router 1, if we do show IP EIGRP topology, and we check here for the 5.5.5.0/24 network, here we have three successors. And as you can see, we have actually, they are all the same. They have same reported distance. So the neighbor here is reporting the same distance, as you can see here. So they're reporting same distance to the 5.5.5 network here. And then we have also their own links here, which are same gigabit Ethernet links. But when we go to this link here, we have a mismatch. So we have an Ethernet link here. And therefore, it is not even meeting the feasibility condition. So if we do the all links, we'll see even more. So we have included it here. So here it is. So it is this link here between the router 1 and router 2. And as you can see, the reported distance is way higher than the feasible distance here. So it will not meet the feasibility condition, and it will not be added into the route table nor the EIGRP table. Of course, we can do something to add the feasible distance via a offset list, and that is something we're going to do. But we're only going to do it to give some of the routes so they become the feasible successor. So let's start with that. Actually, we could do it like this. We could actually start with the, okay, let's go to gigabit Ethernet. Let's just pick 4. We can do a delay. So if we do here, we see, so in tens of microseconds. So let's do like this. Show IP interface gig04. Show interface. And there's the delay. Alright, so now if we do the show IP EIGRP table, as you know, the default is the bandwidth and the delay. So if we modify either the bandwidth or the delay, we will have a different distance. And therefore, changing the delay will change the distance. So let's check that. Show IP EIGRP topology. And let's see here. So now we have, instead of 3 successors, as we had previously, we have only 2 successors. We have one feasible successor. And that was because of the command that we just typed in, the delay command. So let's remove that now. No delay. And let's do it via the offset list instead. So let's do do show IP access list. I think I have one here. Let's remove this second one. No IP access list. Let's see if this works. Yeah, it works. Alright, let's do that. So I created this access list here. And now let's just insert it here. Offset list 1. So we use access list 1, and then we have inbound updates. We'll just add 100 to the metric, and we'll do it on Gigabit Ethernet 4. Right. Now we'll get a resync, and then we're able to see the change. There. Alright, show IP EIGRP topology. And we have two feasible successors still, or two successors, sorry. And here is the feasible successor, as you see here. So it is still less, the reported distance is less than the feasible distance, which makes it a feasible successor. And as you can see here, we have a distance added here of 100 on this distance here. And that is only for the interface which I typed in. So if I do the default, it will be applied on all. So let's try that actually. Let's just see what happens. Sec EIGRP, let's do no. And, let's remove this offset list. And let's do a default. Let's just see. It should actually do no change as it will be applied on all. But let's just try and see what happens. Right, the resync should be anytime here. As you see now, we have a resync on all the neighbors instead of only one neighbor. So show IP EIGRP topology. And here. So we still have three successors. And that is because nothing was changed actually. They all have the same distance, they all have the same reported distance. So they are all successors, equal paths. So that didn't change who becomes a feasible successor, but as you saw when I changed it on one interface, it actually made it a feasible successor. Alright, so that is that with the feasible successor. Now let's do the show IP EIGRP topology all links. Let's see what we have here. Here we have included this link here. So it is this link here between router 1 and router 2. Because of this link here and this link here, meaning they have Ethernet interfaces and not fast Ethernet or gigabit Ethernet, so it's very slow links, and therefore it's adding very high metric here, as you can see. So the reported distance of router 2 is very bad, as you can see here, and therefore it will not meet the feasibility condition. Because to meet the feasibility condition, the reported distance must be less than the feasible distance. Here, feasible distance. And this one here needs to be less than this one here, which it is not. Meaning it is not added in the table, but we can see it because we typed in all links. So that's the reason we saw it. Otherwise, the successors and the feasible successors are viewed without the all links command, so only like this. So now we see the three successors. Alright, so how does variance work? So variance, let's see here. Let's go to router 1, and for the 5.5.5.0/24 network, we have three routes here, or we have three next hops here. And we have two successors, which are these two, and then we have the feasible successor right here, as you see. Now, if we do the show IP route, we will only see two next hop. So we don't see the third one. And that is because we have not included it through the variance command. So what the variance command will do is that in case this one is not less than the feasible distance, what it will do is it will only multiply. So for example, if we do variance 2, it will multiply this one here, feasible distance, by 2. And then it will check the reported distance of the feasible successor. And if it is less than the sum of the times 2 of this one here, so if we do like this, calculator here, and we do times 2. So if this feasible successor, as we see, it is less than this number here, meaning it will be installed in the routing table. As we see now, it is actually already, let's see here if it is less or not. Yeah, it is already less than this number here, but for some reason you'll have to configure variance for that to take place. So let us do that and do variance 2. Show IP route, and now we have it included right here. So let's see actually what we had before that. So show IP route there. Let's see. 5.5. Alright, so we have the same, as you can see here. It is the same distance. So show IP EIGRP topology. Let's see. They are actually different here. But when I entered the variance, it added them in the routing table. We should see the times 2, but unfortunately here we're not seeing it. But this is how we do the variance to get the routing tables. This will not work for routes that are not feasible successors, meaning, let's do the show IP EIGRP all links. So variance command will not work on this one here. He is not included. He's just taking memory, but he is not included in the EIGRP table at all. So he will not be affected, and he will not be included in the routing table when we do the command. So that is the variance command, and hope this was helpful video. Thank you guys for watching. Bye.